Let's talk about how do we implement this strategy pattern in our tennis complex application. So in tennis complex, we'll have booking. Booking will have save payment info behavior, right? Which will require some kind of payment object, right? When we started the application, there was only one type of payment allowed. Users will do cash payment. So there was no problem, right? Save payment info will save information like amount and currency distribution, maybe, right? Later, users started demanding that they also want to use their credit cards and debit cards, right? So now we have one behavior, cash payment, card payment. So can you see this situation? It is very similar. We have one client of booking which is going to use this save payment info, or let's say make payment, right? Make payment method, which will require some instance of payment class, right? Earlier we had only one payment class because there was only one kind of payment, cash payment. Now we have cash payment, card payment, and let's say net banking, right? So we have three different kinds of payment mechanisms in our system. Now we can use strategy pattern here. Why? Because we want to separate, we want to decouple the client which is consuming this behavior from the family of behaviors. So what we'll do, we'll create a interface. Let's say payment kind of interface, right? And we will encapsulate the algorithms. We'll create a class for cash payment. So we'll say pay method here. Cash payment will have its own implementation of pay method. Card payment will also implement payment interface. It will provide its own way of doing payment, like saving card details and everything. And net banking will also implement this payment interface, and net banking will have account number, bank name, user ID, something like that. So this is a family of algorithms, while each algorithm is encapsulated into classes. Why they are family? Because they are adhering to a standard, that is payment interface. And now here we will program to super type, we'll program to interface. So in make payment, we'll have, let's say I payment, we'll call this as I payment interface. And it will require instance of I payment P. So let's say user 1 who is doing booking wants to do card payment. At runtime, he has this option, right? On his user interface page, there are options: card payment, cash payment, or net banking. At runtime, he can choose cash payment, card payment, or net banking. So there's a flexibility. These algorithms, these behaviors are interchangeable, right? And they can vary without changing the client. That means tomorrow we want to give discount on card payment only. So we can change the code of, we can reduce the amount here. And you don't have to make any change in your client code. You can change net banking. You can give more discount on net banking. Or tomorrow you can add another new way of payment. Let's say wallet payment based on any wallet system, PayPal or Paytm or Freecharge, right? And it will plug in. User have one more option at runtime. Instead of 3, it will have 4. And let's implement this strategy pattern solution in using programming examples in our tennis complex application. So let's start with our programming implementation of strategy pattern. Let's just first run our tennis complex application. Book and play. Fancy name. So I've created this one user. So I'm using this framework called as Grails. It's a MVC framework. It uses a language called as Groovy, but this language is very similar to Java. It's a superset of Java. So you will see me using Java classes, write Java classes for implementing our design patterns. If you want to know more about the basic fundamentals of how to use this Grails framework. I have put two videos to get started with Grails. You can just check them out. So let's just log in with this user. And right now the application is very simple. You can book code and you can view your code bookings. So I'm gonna just go and book the code. As I said in the beginning, the functionality is really simple. I just have to select the code and the rates are also given 300, 250. So I'll just say code 2, 250. I'll select the date as 4th of August. I'll just say create. And here is my booking, right? 250 rupees by the name of this user. I'm not that user, by the way. So it's just more or less cash payment, right? So it's pretty fairly simple. So let's look at the database and check it out. There's a row with amount as 250 and to which booking it belongs to. That's it, right? The code is fairly simple. What happens is that if you go to booking controller, right, there's this, you'll have one save booking method, right? This is the code where you save the booking. In your booking.payment, so every booking has a payment. If you look at the booking model, right, a booking has one payment. A booking has one payment, right? And payment is a class. Payment is another domain class. That is another model. And the payment has amount, timestamps, and it belongs to booking. It has a booking ID, right? Now, so it's fairly simple. So when I create booking, I'm just saying that booking.payment equal to new payment, amount equal to the code that you have selected, booking.code.rate. Every code has a rate. So if you look at the code model, every code has a name, code 1, code 2, code 3, code 4, and it has a rate like 300 bucks, 200 bucks, something like that, right? So it's fairly simple. So what I'm doing is I'm getting the amount from rate of the code and creating a payment object and assigning it to booking.payment, right? Right. And then I'm saving the booking. That's it. Fairly simple. Now our users have asked for more payment methods. They don't just want to pay by cash. They want to have card payment, net banking, and wallet payment, like their private digital wallets, and yeah, existing cash payment also. We want to implement strategy pattern because we want to keep this. A user can select runtime any behavior. He might want to pay someday by cash, someday by debit card, someday by net banking, some other time by wallet, and you don't know till runtime how he's going to pay. And so we want to have our algorithms loosely coupled with the client. In this case, our client is booking. Booking class is our client because booking has one payment. So we want to keep these payments fairly loosely coupled from booking because user can choose with different users can choose different modes of payment every single time, right? What is going to change when we introduce new payment options? So I want to have two changes basically. I want to offer some discount when somebody books code using net banking. I want to offer, let's say, 15% discount. Using debit card, credit card, let's say 20% discount. Using wallets, I want to offer 25% discount. So that is going to change. And now that we have introduced these new payment methods, we will need to save more information about them because cash is simple, like you collect cash. But if somebody is paying through net banking, we'll have to store some extra information such as bank name and card number in case of card payment. In case of wallet, again, username, password for that wallet system. And what is the wallet system? So these are the things which are going to change. Because we want to implement strategy pattern, let's first define a standard for having this payment process, for saving this payment information, right? So let's define standard for it. Let's create one interface. So in our services folder, let's create a new package. let's say com.bbarters.service, right? And in this package, let's create a new Java class. Let's call it as I payment info, right? And let's make it as interface. Okay. Okay. In this file, we are going to need a method. We are going to set the standard for creating our family of algorithms, family of behaviors. That is card payment, net banking, and all those, right? So we will say public void save payment info. So as I said, we want to change two things in each method. We want to offer certain discount and we want to have different relevant information about each kind of payment. So I'll say integer amount I need. I need the amount, the original amount from the code booking, then only I can apply discount. And then I need uh, JSON for storing the payment info. So this is pretty much it, my standard I payment info to store the payment info and give discount, right? So this is my interface. So this will help me to create family of algorithms in my strategy pattern. Let's now go and encapsulate our different payment behaviors. Now in here, if you see in our model class, we only have one single payment class, right? Which was perhaps the best solution when we had only cash payment. But now that we have these different modes of payment, what I'm going to do is I'm going to implement something called as single table inheritance. What you understand by single table inheritance is that I will have this payment class as abstract class. There will be no simple payment. There will be either cash payment, card payment, net banking, or wallet payment, but there's no payment. It has to be a specific kind of payment, right? So what I'm going to do is I'm going to create a few more models. So let's say I'm going to create card payment. And what I'm going to do in that card payment is that card payment extends payment class, right? So in Grails, for using single table inheritance, you have to specify discriminator for each children class. So what this discriminator means is that the value for column class will be card whenever you are creating an instance of card payment, right? Apart from that, what we are going to do is we'll also make sure that we will provide our card payment behavior. So it has to implement our I payment info interface, right? In our payment model, we need to add a field for storing the payment details. So JSON object, and let's say payment underscore info. So we'll do that. In our card payment class, as I said, we want to give certain discount on the final amount. So in card payment, I want to give 20% discount. So I'll say this dot amount, the final amount equal to whatever the amount that has been given to us when the user selects the code and the amount is determined based on code charges. It will pass down here in the form of parameter and then say AMT star 0.8. So that will be our final amount that with 20% discount. And then we'll say this dot payment info equal to this JSON object pinfo. Cool. So why it is a JSON, this payment info? Because I don't know what kind of information I'm getting. So I don't want to create multiple columns for different kinds of payment info. Rather, my idea is in my payment table, I'll have just one column called as payment info, and it will be a JSON. So it's a flexible arrangement. JSON can have different kinds of fields. There's no restriction upon type of field. So for card payment, the JSON will be like card number, card type, bank card issuing bank name, something like that. For net banking, it will be bank name, account number, and so on and so forth. If you want to store miscellaneous information, which is going to be different for different rows in your table, it's advisable to use the column as JSON because JSON can allow you to do that. So I'm going to do that. Cool. So this is my one behavior. So I need to provide behavior for net banking, wallet, and cash payment, right? So let's do that. And here the discriminator will be net banking. In net banking, I'll give 15% discount, 0.85, and I'll say this dot payment info equal to p info. Cool. Obviously, this net banking payment has to extend the payment and has to implement the iPayment info interface, right? Similarly, we'll create two more, that is wallet payment and cash payment, right? So I'll quickly write the code for these two. They will have different discounts. All right, so here is my wallet payment class. Again, it implements the iPayment info. We are providing implementation for save payment info method. Uh, it has a discount of 25% on the amount of booking, and also it will store some payment info in the form of JSON, right? So that's pretty much it. So now what we have done with this code is that we have formed a family of algorithms. We have encapsulated our different payment behaviors into classes and formed a family because they are all implementing a common standard in the form of iPayment info, right? So we have created a family of behaviors, and our client is our booking class, has a super type instance, has one payment, and we can provide uh, any instance of either card, cash, net banking, or wallet, depending on the runtime choice of the user. This is our strategy pattern. Because client and behaviors, the payment behaviors or payment options are so loosely coupled, right? Because we are programming to a super type here. So runtime user can decide to choose among card payment, cash payment, net banking, or wallet, and we'll create appropriate object and pass it on and assign that object as a payment option for that particular booking. They are loosely coupled. So fantastic. Going forward tomorrow, we can make changes in the discount scheme. We can change the discount percentages. We can remove the discount, or we can even add a new payment method like barter payment or something like that, and without disturbing our booking class. Awesome. So this code looks good. So create booking is pretty straightforward. This UI was meant for cash payment only. So I have to make the necessary changes for user to be able to decide runtime which kind of payment he or she wants to make. Right? So I'll make those changes in UI and slight adjustments in my controller, and that will be it. So let's do that. Right, so we are ready with all the changes in our views and controllers, right? Whatever little was needed. So I'll just log in again. And okay, so a bit better UI, you would say. Yeah, so book code. And now we have our codes to select. So I'll select code number 1, rupees 300. Okay. Date of booking, I'll select it as 5th of August. Yeah, cool. So now we have options for payment, right? So we have cash payment, we have wallet payment, we have card payment, we have net banking, right? Okay, so let's just do card payment. So I'll say issuing bank name as Bank of America. Okay, card number. Okay, 1, 2, 3, 4, 5. CVV. Oh my God, 678. Awesome. So that's 300, right? And 20% off. So I'll say create booking. Okay, awesome. So booking is done and total payment was 240. Is that okay? Yeah, I think so. So I got 20% off on my card payment. Let's see the database entry, what has been there in database. So I'll go in database. So there's one payment of 240, and look at this payment info JSON that I was talking about. Card CVV, card number, and issuing bank name is there in one column, right? And I told you in single table inheritance, in this payment table entry, the class is card. It's a card payment. It's an indicator that it's a card payment. Let's go and do one more payment. So let's go home and let's say book quote, and I'll book for 9th of August. I'll make quote 4, cheaper quote. I'll say this time I'll say net banking. Yeah, why not? I'll say, and account number is 112345678 Pretty good. IFSC code TFC 00078. Okay. And I'll say create booking. So 200 and 15% off. So 170. Awesome. Nice. And let's go and check this payment entry now. So the payment information is there, account number, IFSC code, and bank name. And you can see the class column has the entry of net banking right now. So this is single table inheritance. We are creating the objects of net banking payment, card payment, and they are all being stored inside our payment table in our database, right? Because they are all inheriting the payment model. Awesome. So I want to just show you what I did behind the scene in my controller logic a bit, so, right? So in my booking controller, in the save method, okay, I received the form, the HTML form through my params method that is accessible in Grails to get the params submitted in the form. And I had always named all my params as payment info, right? So I converted them into JSON object, because you remember my data type in my payment model for a payment info was JSON object. So I converted them into JSON object. Booking has a payment. You remember that booking has a requires a instance of payment. Payment is our superclass. So I need that payment instance, right? So I created this service, payment service, and it has a method, static method called as create payment. So I'm passing on the payment type parameter, which I'm getting from my form, HTML form. So payment type will depend on which payment type I'm choosing here. So that will set the payment type. It's a hidden field in my form, right? That payment type, because that will help me create the instance of specific type of behavior, card payment, cash payment, or something. And then I'm passing which quote he has selected, right? So the quote, the rate of the quote, which will be my amount, initial amount. And then p info is my JSON that I created from the HTML form, right, for different kinds of payments. In this create payment method, so I'm getting that payment type string from the HTML form, right? I'm using it to create an instance. So you can create an instance from a string name. You can create class name. So you get a string name such as, let's say, card payment or card. You can use that card payment string to create an object of card payment class, which is what I'm doing here. And then I'm passing that instance to my save payment details method. Save payment details method requires a iPayment info. In our family of algorithms, iPayment info was our interface. So that and integer amount that is coming from rate of the code selected, and the payment info JSON. When you are calling this save payment details method here in this service, that P instance of iPayment info interface will be different. When the payment type is card, we will get a card payment instance. That will be P. When we say cash payment, this will be a cash payment class instance for this P. So they will substitute here, and we'll just invoke this save payment info method of respective card payment or cash payment, so no discount, wallet payment, 25% discount, and net banking payment, 15% discount, right? So that is basically it. This is the way you program this strategy pattern. See, this is all Java, by the way. You can explore this source code. This is available in my Git repository. It's a public repository. I'm putting the links in the description section of the video, so please go and have a look at it. Again, just to round off the discussion, we use strategy patterns because we wanted to decouple our different payment behaviors, different payment methods with the consuming client class, that is booking class, right? I'll see you next time discussing and implementing another object oriented design pattern.